and welcome to the Physics of Swimming. Today you'll be learning about the different physics properties involved in the 50 freestyle.
Okay, so what are we studying? The 50 freestyle is an Olympic swimming event where the swimmer is allowed to do any stroke, but they will typically do the American crawl, commonly called the freestyle stroke. The swimmer must do one lap on a long course pool. This video will describe the physics properties involved in the 4 components of the 50 freestyle race, including the start, the stroke, the flip turn, and the finish. The first aspect of this race is the dive. First, the swimmer pushes off the block and accelerates outward. When a swimmer is in the air, their body is a projectile. The path of the projectile is known as its trajectory. This diagram is used to represent the acceleration that happens during a swimmer's dive. In short, V sub I represents the initial velocity, and V sub F represents the final velocity. Using the Pythagorean theorem, this equation proves that the final velocity of a projectile will be faster than the initial velocity, due to the acceleration of gravity. So, the final velocity in the x direction is 10 feet per second, as I have measured. And the final velocity of the y direction equals the acceleration of gravity, or 32 feet per second. So v sub f, or the final velocity, equals the square root of the quantity v sub fx squared plus v sub fy squared. By substituting in the values, the answer comes out to 34, which proves that gravity will accelerate a projectile downwards, since the initial velocity was 10 feet per second and ended up as 34 feet per second, due to gravity. Once under the water, the swimmer enters a whole new playing field, so the water is 700 times denser and 55 times more viscous than air. The 4 forces that act upon a swimmer when they are submerged are buoyancy, drag, gravity, and propulsion. There are various types of drag that affect the swimmer, but the first is frictional. The velocity of the swimmer, their surface area, and their shape all play a part in frictional drag. It's time for a swimmer fashion show! Swimmers will wear swim caps, specialized goggles, and knee-skin swimsuits to keep down frictional drag. There are different types of drags, though, other than friction. Now remember, moving water has a lower pressure than stationary water. As a swimmer's speed increases, pressure accumulates around their head, and this creates a pressure difference between the head and the feet. The difference in pressure creates turbulence behind them as they move through the water. Another type of drag that swimmers will experience is wave drag. This happens when there is a difference in water velocities between the water that is directly touching the swimmer and the water surrounding the entire moving mass. This process creates waves. The swimmer may get stuck in a pocket of water if the length of the wave equals the length of the swimmer. This is the equation to calculate the drag force acting upon the swimmer. A swimmer will use their arms and legs to help them move through the water. By adding kicking, the swimmer will stabilize and propel themselves. They
use their arms to pull themselves through. Most swimmers think it is more effective to push your hand past your body. Rather, it is more effective to pull your body past your hand. In this demonstration, the pool is in long course. So, that would mean that you would not do a flip turn on a 50. But in most cases, in short course orientation, there would be one flip turn. So it is important to know about the flip turn. The swimmer moves in a linear momentum, and when it gets to the wall, they convert to rotational momentum, and once they push off, it is converted back into linear momentum.
And off of a starter turn, a swimmer will use dolphin kicks to propel themselves forward in streamlined position. And off the race of a lifetime, she comes in as streamlined as possible to finish the race, and she wins! So to review, today we have learned about the forces that act upon a swimmer when they are in the water, how gravity accelerates a swimmer in the racing dive, and the physics principles that are applied to each phase of the race.
Thanks for watching!